For the last 2 years, the AI industry has been obsessed with a single word: scaling. The logic was simple: more data, more GPUs, and bigger models would eventually lead us to AGI. But recently, we hit what experts called the wall. Standard large language models started plateauing. Simply feeding GPT more of the internet wasn't making it smarter, it was just making it more expensive. But over the last few days, a massive shift has been confirmed. We are officially moving past the limits of traditional LLMs. Between OpenAI's Strawberry reasoning breakthrough, Google's Gemini 2.0 pivot, and the emergence of System 2 inches thinking, the rules of the game have changed. We aren't just talking about better chatbots anymore. We're talking about models that can actually think before they speak. So today we're breaking down the new AI updates that confirm we've finally surpassed the limits of the LLM era. Let's dive in. To understand why this new update is such a big deal, you have to understand the failure of the old way. Traditional LLMs operate on what we call System 1 inch thinking: fast, instinctive, and emotional. When you ask a standard GPT-4 model a question, it predicts the next token instantly. It's a sophisticated autocomplete. However, internal reports from OpenAI and Meta recently confirmed that the scaling laws for pre-training, basically adding more data, are hitting a point of diminishing returns. There isn't enough high-quality human text left on the internet to train a model 10 times bigger than GPT-4. This is where the new update comes in. Instead of just scaling training, the industry is now scaling inference. This is the birth of the large reasoning model, LRM. The first real confirmation that we've moved past LLM limits came with the release of OpenAI o1, formerly known as Project Strawberry. This isn't just a version 5 inches of GPT, it's a fundamental architectural shift. Traditional LLMs fail at complex logic because they can't plan. They start writing the beginning of a sentence before they know how it will end. OpenAI o1 fixes this by using chain of thought processing. It's essentially a hidden layer of deliberation. Before the model gives you an answer, it spends seconds or even minutes running internal simulations, checking its own logic and correcting its mistakes. On benchmarks like the International Mathematical Olympiad, IMO, qualifying exam, GPT-4o only solved 13% of problems. The new o1 model, it hit 83%. That's not a marginal improvement, that's a paradigm shift. We've moved from a model that guesses to a model that reasons. The technical term for this new frontier is inference-time scaling, or test-time compute. In the LLM era, intelligence was baked in during training. Once the model was finished, it was as smart as it was ever going to be. But with the latest updates, we've discovered that you can make a model significantly smarter by giving it more time to think at the moment you ask the question. Think of it like a human taking a test. A traditional LLM is like a student who has to shout out the answer the second they finish reading the question. The new reasoning models are like the student who gets a piece of scratch paper and 5 minutes to work through the logic. By spending more compute power at the moment of the request, these models are bypassing the architectural limits that held back GPT-4 and Claude 3. OpenAI isn't the only one breaking these limits. Google's upcoming Gemini 2.0 update is reportedly built specifically to compete in this reasoning category. While Gemini 1.5 Pro focused on long context, being able to read 1 million tokens at once, Gemini 2.0 is pivoting toward agentic behavior. The rumor mill and leaked documents suggest Google is integrating Project Jarvis, an AI agent that can take over your web browser to complete tasks. This requires the model to go beyond simple text prediction. It has to understand cause and effect. If an AI is going to buy you a plane ticket, it can't hallucinate. It needs a reasoning engine that confirms the price, checks the dates, and validates the payment. By moving toward agents, Google is confirming that the text-in, text-out era of LLMs is over. We are entering the action era. One of the biggest limits of traditional LLMs was memory. You might remember the goldfish effect, where you'd have a long conversation with an AI, and by the end, it forgot what you said at the beginning. The newest updates have essentially shattered this wall. We've seen the jump from 128,000 tokens to 2 million tokens in Gemini. And now, new research into ring attention and infinite context suggests we are moving toward models that can process entire libraries of data without losing a single detail. But it's not just about the size of the memory, it's about the retrieval. Traditional LLMs get lost in the middle. They remember the start and the end of a document but forget the center. The new updates utilize a technique called needle in a haystack optimization, ensuring 100% recall across massive data sets. This means you can feed an AI your entire company's codebase, every email you've ever sent, and 10 years of financial records, and it can reason across all of it simultaneously. That was impossible 6 months ago. Perhaps the most significant confirmation that we've surpassed LLM limits is the shift from prompting to workflows. In the old LLM era, the quality of the output depended on how good your prompt was. If you didn't give the AI the right instructions, it failed. The new update philosophy, championed by companies like Anthropic with their computer use capability, changes this by allowing the AI to refine tasks autonomously without needing a human to guide every single step. This evolution means that instead of you telling the AI how to do a task, the AI figures out the steps itself, effectively turning the prompt into a high-level goal, rather than a set of manual instructions. Anthropic's Claude 3.5 Sonnet can now literally move a mouse cursor, click buttons, and type text in a virtual environment just like a human. This is agentic AI. It breaks the limit of being stuck inside a chat box. When an AI can use a computer, it's no longer just a language model, it's a digital worker. The final limit being surpassed is the data modality limit. LLMs were trained on text, which meant they only understood the world through how we describe it. They didn't understand physics, gravity, or spatial reasoning. But with the arrival of models like OpenAI's Sora and world models from startups like Wave and Runway, AI is beginning to understand the physical world. By training on video data and 3D environments, these models are learning intuitive physics. When you see a video of a ball bouncing generated by an AI, the model isn't just predicting pixels, it's simulating the trajectory. This world modeling is the missing piece for robotics. If an AI understands how a cup of coffee spills, it can eventually be put into a humanoid robot body to clean it up. So, let's wrap this up. What does it actually mean when we say a new AI update confirms to surpass LLM limits? It means three things. Reasoning over prediction. We are moving from models that guess the next word to models that plan their logic. System 2, thinking. Inference scaling. We found a way to make AI smarter without needing a bigger brain. We just give the existing brain more time to think. Agents over chatbots. AI is moving out of the browser and into our operating systems, taking actions instead of just giving advice. The scaling wall that critics talked about for months, the industry just walked around it. By shifting the focus from pre-training to reasoning and agents, we've unlocked a new path toward AGI that doesn't rely on just more data. The pace of these updates is genuinely hard to keep up with. We went from AI can write a poem to AI can solve PhD-level physics and use a computer in less than a year. If you want to stay ahead of this curve, you need to be watching the architecture, not just the version numbers. And for that, you have to subscribe to the channel. The LLM era was just the warm-up. The reasoning era is the main event. Thanks for watching. If you found this breakdown helpful, like and share this with friends who like updates.